TSE Physics 2016 Structure Question 1. So you are provided the following apparatus for doing an experiment to find the specific heat capacity of bronze, Cb. So we have a bronze sphere of mass 0.8 kg hung with a thread and room temperature. A polystyrene cup, water bath, maintain 80 degree, thermometer, stirrup, tower. So what we are trying to do here is that we would like to try to measure the specific heat capacity using the mixture method. So this is what we are going to do. We will put the bronze ball into the water bath, not 100 degree, but okay, 80 degree. And then we would take it out. The metal ball will be at 80 degree, so we dry it with a towel, and then we will put this 80 degree bronze ball into a cup of cold water, which we know the temperature at T0 room temperature, and finally we use the thermometer to measure how high the temperature will it gets to. So let's describe what we are doing. Firstly, we put the sphere into the water bath, hot water bath. For a few minutes, then take it out and dry it with a towel. And then we will transfer the sphere into a polystyrene cup of water, and we'll measure the final temperature, TF, of the water with a thermometer when it gets to equilibrium. So in order to calculate for the specific heat capacity, we can use the concept assuming no heat loss to surroundings. So heat loss by the bronze sphere will be equals to heat gain by water. So heat loss by the bronze sphere is calculated by this MC delta T, and for the water it is calculated by this. And so make Cb as the subject because we want to find the value of Cb. Cb will be equals to this expression. So finally, you are asked to give two experimental precautions to be taken. Okay, firstly, we have to dry the sphere with the towel quickly before putting it into the cup, because we don't want any hot water to adhere to the metal sphere, which will affect the result. We will give extra energy to warm up the water, so we need to dry the metal sphere before putting into the cold water. Secondly, we want to make sure the sphere is fully immersed in water so that there will be no heat loss to the surroundings. If the sphere is not fully immersed, heat may loss to the surroundings. But if it is immersed in water, the heat must go into the water. Thirdly, we can stir the water thoroughly before taking the temperature, in order to ensure that the temperature inside the water is even, so that your temperature measurement will be more accurate. Okay, lastly, the value Cb found in the experiment is lower than the actual values. That means Cb measured is lower. So there must be something wrong. You can say heat loss to the surrounding. One of the reason heat loss to the surrounding, because of the heat loss to surroundings, that means some heat has gone away. We expect this is 80 degree, but actually it's not. Maybe it's 78 degree. So when you put into the water temperature rise, but not rising as high as it should. Okay, originally we expect it's 80 degree, the water temperature rise high. But if it is only 78 degree, the water temperature may just rise a little bit less than before. So the temperature rise of water, delta TW, is smaller than it should be. So if the delta T is smaller, then left hand side Cb would also be smaller. Measured value of Cb is smaller than the actual value.